All right, let's take a look at angles of triangles and finding measures. So, in a triangle, when we're looking to find angle measures, the first thing to be aware of for all of these problems is that all triangles, if you add up the three angles in a triangle, the sum must be 180 degrees. It can't be more, it can't be less. So if we look at the first problem here, we have 100, we have 40, we have x. We're looking for that last angle. You can take 180 and you can subtract the sum of the other two angles, which would be 140. And that would end up being 40 degrees for that last angle. Let's take a look at this bottom problem here. They must add up to a total of 180 degrees. So I will add together the two angles that I do know. It comes out to be, when you add these two together, you have 118. And I'll take 180 degrees minus 118. And that comes out to be 62 degrees for that missing angle. Take a look at this one. We know it has to add up to 180. We have 139 if we add together the two angles that we do know already. So we can do 180 minus 139. Comes out to be 41 degrees for the missing angle. Take a look at the next one. We have 42, 38. We know it has to add up to 180. So 42 plus 38 comes out to be 80. And if we subtract 180 minus 80, the missing angle is 100 degrees. What is the measure of the missing angle here? We have 58 and 42. If we add these two together, that's 100. We know it has to add up to 180. If we subtract, the missing angle is 80 degrees. 180 minus 100. In this triangle, we have 50 and 50. We add them together, that's 100. So that means my missing angle has to be 80 to add up to make the 180 degrees. Now, this particular problem, we're trying to find the measure of angle C. Okay, we know the triangle adds up to 180 degrees for the total. And they give us one angle. Okay, we have two angles we don't know. But I do notice something about this triangle. Two sides are the same. This is an isosceles triangle, which means if I have two sides the same, I also know that these two angles across the sides are the same as well. So what I'm going to do in this situation is that I'm going to do 180 minus the 112 that I do know, and that comes out to be 68. Now, we have 68 degrees left for two angles. We got this angle and this angle. We don't know their measures, but we do know they're exactly the same. So we could divide this by 2. That means these other angles I don't know are 34 and 34. So the measure of angle C is 34 degrees. That would be my answer, 34 degrees. Because they're asking for the one angle, not the total of the two, just the one angle. In this problem, I do notice that we also have an isosceles triangle again because of these two lines. I know that the sides are the same and the angles that are across them are the same. Well, if this angle here is 36 degrees and this angle is 6x plus 12, I know they're equal, so I can set them equal and I can solve a two-step equation to find x, and that's what they want, to find x. So I will minus 12 to both sides, and that's 24 equals 6x. And then I'll divide by 6, and x will equal 4. The key to this problem is knowing that these two angles are the same because it's an isosceles triangle because the sides are the same. In this problem, this triangle is an equilateral triangle. Okay, so all the sides are the same. Something else we know about equilateral triangles is all the angles are exactly the same. And one step further, we learned the other day these angles are all 60 degrees. This angle here is also equal to 8z minus 12. So I can write an equation where I know that that angle this angle here is not only equal to 60, but it's also equal to 8z minus 12. And now I have a two-step equation I can solve, where I can add 12 to both sides of the equation, and that gives me 72 equals 8z. And my last step will be to divide by 8 on both sides, and z will equal 9. And that's my answer. Z, the value of z is 9. We also, in the next problem, have an equilateral triangle again. And in this equilateral triangle, we know from the last problem that these angles are 60. So the measure of this angle is not only 60, but it's also 8z plus 4. So I can write an equation where I can say that that angle is equal to 60 and 8z plus 4. That gives me a two-step equation to solve, where I can minus 4 to both sides. That gives me 56 equals 8z. Divide by 8 on both sides. Z is going to give me 7. All right, we got a couple more example problems here. Let's take a look at the first one. Since this is an equilateral, we know that this is equal 60 because they're all 60. So the equation for this problem is going to be 60 equals the expression they gave me, 2n minus 2, two-step equation, add 2. That's 62 equals 2n. And you're going to divide by 2 on both sides, so n would be 31. This problem here, we have an isosceles triangle because of these two marks here. Those sides are the same, so these angles are the same. So that means that both these angles are 48, and if I know this angle is 48 degrees, and I know it's equal to 3x plus 60, I can write that equation. I can say 48 equals 3x plus 60, and that's going to give me a two-step equation to solve. I can minus 60 to both sides. It's going to give me negative 12 and 3x. And then to solve for x, I will divide by 3 on both sides. In this case, x is going to be negative 4.